Hi, this is the first video for COM 345. This is Advanced Program Design with C++. So my name is Joey Paquette. I'll be your instructor for this semester for both of the sections, Section D and Section N. This video is presenting the first part of slide set number 0. So there's going to be two parts. This is the first part. This is going to be for the introduction to the course, giving you general information about what this course is, what are the components of this course, how I'm going to present the course, the material, the resources available for this course. So I can share my screen here to show you what most people would be starting with, which is a Moodle page. So first of all, there's two sections. I'm teaching the two different sections for the course. So you will see only your own page for your own section, but don't worry. Both of the sections are taught exactly in the same way. So what you see here as Section D, the exact same thing is available for Section N. If ever you become aware that there's a difference between two sections, please contact me and I will fix it. So as you see here, I've already prepared all the material for every week that is coming. I invite you to look at the dates, so on. All the videos are already there. These are the videos I prepared for last year. That's mostly how I'm going to assume that you're going to absorb the material for the course. So there is, for every slide set that I prepared, there is at least one video for every slide set. So these videos are public. They are on my YouTube channel. So if you go on the YouTube channel, you'll see the sequence of all the videos. So this is mainly how the material is going to be given to you in the course. Now that's how I used to do it last year when we were in lockdown. As this year, we are not in lockdown anymore, but we've been told to do some in-person activities. That's what I'm doing. So essentially what's going to happen is that, yes, you're going to have all the videos. This is how I'm giving you the material, but once a week, I will be in class to do a regular lecture. Well, I'm not going to repeat everything that's on the videos. Essentially, I'm going to come to the lecture time. Then I'm going to assume that you've listened to the video that pertains to the current week or where we are at this point in time in the sequence of videos. And then I'm going to assume you listen to the latest video, and then I'm going to discuss. I'm going to select some topics that are discussed in this video, and I'm going to basically go over them and then have some discussions, hoping that you will be prepared and have some questions about this material. So once a week, there is going to be one lecture session in which I'm going to be in class doing a regular class. The other session for the week is going to be a Zoom session where I will essentially do the same. So only one class will be in person. The other class will be, or the other session will be on Zoom. None of these synchronous sessions, Zoom sessions, synchronous sessions are going to be recorded. And I'm not going to record either the live sessions that we do in person. So if you want to participate in discussions, you have to come, and it's not going to be recorded. You have to come in person yourself, either on Zoom or in person in the classroom. It is not going to be recorded. However, it's important that you understand that during these sessions, I'm not going to present new material. Okay, so you can absorb all the material by using only the videos that I have produced, such as this one. Okay, I invite also you to, of course, to look at the sequence, especially that you have, for example, assignment number 1 is due on week 5, assignment number 2 and 3 are due a little bit later. You have the midterm that is on week 8, the final, and so on. So a lot of things here are already presented. So all of the things that are going to happen are already presented here. You want to know about the course outline, here it is. So one of the things also is that I have my own website, which I maintain, which I've been using before I started using Moodle during the pandemic. Before the pandemic, I used to have only my own web page. Here it is. So if you click here, so that brings you to the web page for this course. If you go on my web page, you can see that I'm presenting myself here. The most important thing for you, I guess, is teaching here. This is a link to this course that we're talking about here. You may be interested in seeing all the other classes that I've ever taught since I've been a prof. Here at Concordia, you see that I started in the fall of 1998, so it's been quite a few number of years here. So I've been teaching this course for a very long time. You can access also the previous times the material related to the previous times I've taught this course, the latest one being the current one, which is fall 2021. There's also other information here about me or my research or so on and so forth. Feel free to read if you feel like so. So this is our webpage for the course. This is essentially presenting exactly the same thing again as what you have on the Moodle page. Don't expect that there's more things here. Okay. As far as I'm concerned, people will always go to the Moodle page. Some people might come here, but don't expect that there's more things here compared to the Moodle page. In fact, as I was presenting you earlier, if you go to the Moodle page, and for example, you click here, so the handout for the project description, which I'm going to talk in an upcoming video, is here, which is a link to my personal web page, a file that is stored on my personal web page. So all the files that I'm posting are hosted on my personal web page. You might see that brings you to a page like this. Or no, not this one. Yeah, so here you might see that it presents you with the history of the commits essentially I made to the website. So you might, for this one, there's only one version, but eventually there are likely to be more versions because sometimes I post different versions of the same file. So if you want to see if there was a change, then you will see here that there's going to be more versions. Of course, I'm going to try to make it so that there's only one, but sometimes there are mistakes and then I fix them and then you will see them appear in the list here. Okay, so let's go back to the Moodle. Okay. So our interest here is slide set 0. So these are essentially PowerPoint slides that I've designed. So if you click here, you get access to the PowerPoint for each of the slide sets. Then let us, okay. First of all, what we do normally in a course, we go over the course outline. However, I have designed a slide set that actually essentially presents the course outline. Okay. So that's why here we're going to go and the slide set here. Okay. Okay, so here this slide set 0 has 2 parts. First, introduction to the course, which I'm presenting right now. And then second part is introduction to C++, which is presented in video number 2 for week number 1. So as I presented myself earlier, my name is Joey Paquette. I've been here in the Department of Computer Science and Software Engineering for more than 20 years now. So my teaching topics are essentially all revolving around the usage of programming languages, or even design of compilers, which is implementation of programming languages. I also teach often some graduate software engineering course, core course, which I essentially teach how to do programming in the context of software engineering. It's all about how to use and design programming languages. My research topics also revolve all around the use and design of programming languages. More specifically, I do some research in demand-driven computation models and context-driven computation models. Also with parallel and or distributed computing. So I do also compiler design in my research, in my own research. So this is the address for my webpage, my personal webpage that you have a link for it in the on the Moodle page. My email address is the following. You might see other email addresses floating around, like joey.packet@concordia.ca. You might see packet@encs.concordia.ca. These are all funneled to the same place. Whatever one you're using, it all comes to me anyway. So don't worry too much about that, about which address you're using to contact me. My office, you might know that the Department of Computer Science and Software Engineering has moved to the ER building. So that's up and on Guy Street. So that's called the ER building. I am on the 11th floor of the ER building, room 1164. The office hours for this course, these are Zoom office hours. I don't have in-person office hours. These are on Wednesdays from 10 a.m. to noon. So if you have anything that you want to discuss personally with me, one-on-one, then this is where you would actually come. I'm also gonna, when I give either a Zoom session for the lectures, or when I go in class, I'm more than willing to, after the lecture time is finished, I'm more than willing to discuss with people after class. So if you have some things to ask me, also one-on-one, then you might wait for the end of the lecture time and come to me, and then we can discuss things. No problem with that. But if you really want to meet with me one-on-one, come to my office hours. So this is the calendar description for this course. I'm not going to repeat that here. So I'm assuming that you have the prerequisites. One of the problems is that you can't take Comp 352 concurrently with this course. Now you have to understand that here I'm assuming that you have mastered the material of Comp 352. So some students often have some problems because I'm using some data structures, and or I'm assuming that you know about the data structures that you're going to use in the project. So yeah, so if you're taking 352 concurrently, then it's an additional problem, but I'm not going very complex in data structures anyway. Just saying, if you take 352 concurrently, it's gonna be maybe a little bit more difficult for you. Here it's listing a lot of different topics. I'm not claiming that I'm covering exactly all of these topics here. What I'm basically, my objective here is to make people functional using a C++ language. Don't expect that here in this course, I'm going to talk about the latest developments about C++. My goal is to, again, make people functioning programmers using C++. It's not about teaching the latest developments. Some of them are very interesting, but that's not the objective of this course. If you want to discuss them with me, well, fine. I'm not going to upfront present you with all the new developments. So why do you have this course? So as you know, in our department, we mostly use the Java programming language, especially to teach programming, like in 248, 249. So Java is a very nice language to learn how to do programming. However, it has its own limitations, as you may know, and also there are things that it cannot do, and also Java is not all there is to learn about programming. There are many programming languages out there that you will have to face and use in the industry. C++ is one of these main languages that you are extremely likely to encounter when you work in the industry. They are, in fact, huge parts of industrial programming that are using exclusively C++. So all of these here topics are typically implemented in C++. So for those of you who know a little bit about C++ and already know about Java, you might be struck by thinking that seem to be a lot of intersection between C++ and Java. So you might feel, oh, because of that, if I know Java, it's going to be easy for me to learn C++. This is kind of a pit trap here. So it's not because it is syntactically very similar to Java that C++ is an easy language to learn for you as somebody knowledgeable in Java. Okay. Particularity of C++ is that in order to use it properly, you have to know how it works, not only how to express your programs, but actually how the programming language actually functions. Very, very often, if you don't understand how the programming language functions in its implementation, you're gonna get in trouble. Okay, so that's why one of the things I do in this course, I teach the programming topics and the constructs of the programming language, but then I also explain how it's implemented so that you understand how to use it properly. Okay. It's notoriously very easy in C++ to write a program, think it should work, and it then turns out to not work, and you don't understand why. With the reason being is because you don't understand how it's supposed to work internally, like under the hood. Okay, so there's not going to be a lot of discussions in this course about how things work under the hood when you actually execute the programs. So some of you might already know some of these technicalities, but there's very often, well, when we teach Java in 248 and 249, it's not necessarily explaining how it works internally. If you don't understand really how it works internally, then you might think that you are a very good programmer. But if you don't understand how it works properly in Java, internally in Java, then when you do C++, then these you're gonna be surprised that you thought you were a good programmer using Java, but when you try to use C++, you'll see that you have many problems. That's very typical of what happens to people that switch from Java to C++. That's one reason why some people don't like C++, because it is required that you know how it works internally in order to properly use it. And if you don't know how it works properly internally, all hell's going to break loose, and then it's going to be very hard for you to actually debug your program if you don't really understand how it works. Okay, so that's why here I'm taking for granted that you already know how to, you're already a programmer, so I'm not gonna, it's not introduction to programming using C++. I'm already expecting that you are a good programmer, and I'm teaching you how to do it using C++. How you will gain practice using C++, basically there's gonna be a project divided in 3 different assignments. And then this is how you're going to get practice using C++. We're talking about the project. So this is a team project. The reason why this is a team project is because, as you see, I actually have in both of the sections grouped together, I have 275 students. I already have a limited number of markers. If I give you a project, and then this is an individual project, and you clearly see that it's impossible, it's not scalable. Okay, that's why we need to have teams, so that the markers have enough time to properly grade every of the projects that are submitted, or the assignments that are submitted. Also, let's face it, when you work in the industry, you almost never work as a programmer alone. Programming is almost invariably a team effort. So it's very important that you get some experience working as teams. Okay, so the teams are going to have to be exactly 5 members. Okay, so don't come up with a request to have a team of 2, a team of 3, a team of 7, a team of 6. It's when you form a team, it has to be exactly 5 members. On the Moodle page, you will see. Okay. I'll come back to that later when I talk about the project. You will see on the web page there is a place where you can actually form the groups by yourself by providing your names and so on. I'll talk about that when I talk about the project presentation of the project topic in an upcoming video. So you must be a team, part of a team of exactly 5 members. So the project is divided in 3 assignments. So essentially incremental development. So I'm stating very exactly what you have to do for assignment number 1. Then for assignment number 2, I'm asking you to add upon what you did in assignment number 1 and integrate the parts of assignment number 1 by providing more functionality. Okay, and that eventually in assignment number 3, you have to, in the end, present the entire integrated project. Essentially doing incremental development. So during the project deliveries, after you submit your assignment, you have to do a small presentation. It's going to be a few minutes demonstration where you have to demonstrate that your code does what was asked in the assignment handout. And also demonstrate that you are using the correct C++ features to implement them. The demonstrations of the projects will be done using a Zoom session with the marker using a shared screen. So there will not be in-person presentations for the projects. It's all going to be on Zoom. Very important. So you will see by either discussing with people from the previous years, or you may try to find online some past code that some students have developed for my projects. You may be able to find some because you will see that I'm very often using the same topics, but warning, I'm always making it somehow different so that it's not a good investment of your time to actually reuse the code that was implemented by somebody in a previous year. So even if you see it's the same topic as last year, you may want to ask your friend about their code and so on. It's going to be different. I'm going to make it so that it's not going to be the same, and it's going to be substantially different enough so that it's not a good investment of your time to actually try to reuse previous year's code. So part of what we have to do in many of our courses is to present the course using what is called graduate attributes. So as you may know, all our programs in computer science and software engineering are accredited. Either software engineering is accredited by the Canadian Engineering Accreditation Board, or CEAB, And the computer science programs are accredited by the Canadian Information Processing Society, or KIPS. So essentially, we do that because, well, for software engineering, we don't have a choice. It must be accredited, but also we did it for computer science. It gives an added value to our programs if they are accredited. When you accredit your programs, and essentially all accreditation boards that I know, they are relying nowadays on what is called graduate attributes, which are essentially describing what are the skills that the students have mastered during the entire program. And then for every course in a program, then you have to identify what are these skills that are exercised and taught in each of the courses. So that's what here I'm presenting, what are the graduate attributes that are introduced in this course. So in order to be properly introduced in a course, these graduate attributes must be taught and evaluated. Many of the graduate attributes are actually introduced in the assignments. So when I present the assignments, you will see that which graduate attribute is evaluated for your assignments. It's going to be stated in the grading scheme of your assignments. So first, all courses have that knowledge base. So this is basically to demonstrate that a student masters the material that is conveyed in this course. So very basic one here. All the courses have that. In particular, for this course, as you know, there is the keyword design in the title of this course. So this course includes graduate attribute design. What is design? Design is the ability to use appropriate knowledge and skill to identify, solve complex engineering problems in order to reach substantiated conclusions. So it's essentially, design is to use your knowledge in order to solve a problem, to figure out how you group together different concepts in order to create a solution. Okay. Essentially here, when I give you the project, I'm going to give you some of the parts, and I'm going to describe each of the parts, and then you have to figure out how to implement each of these parts, and then you're going to have to combine these parts together. That's how we implement design in this course. Another attribute is use of tools. Now, tools, what is tools in software engineering and computer science? Is mostly the programming languages that we use and the libraries that we used, or design patterns that we use. These are tools that we use to actually solve problems. So of course, in this course, what we do is to use the tool which is called C++, and then you use another tool which is an IDE that implements, that provides you with an environment to use C++. You also have to use some libraries to complement the C++ language in order to implement the project. Another graduate attribute is teamwork, or individual and teamwork. So it's essentially measuring how somebody can produce something. You give a task to an individual or a team, how effective are they to actually achieve this task in real life, to construct something in real life using their skills. So in this course, we rely on teamwork. So essentially, I'm giving you a task, and then I measure how you were able to achieve this task. Of course, this is going to be how I grade that is essentially how much you got on the overall grade for the entire assignment. Maybe here, it's important to kind of introduce here a little parenthesis here. When you work as a team, what I've decided to do is that everybody is going to get the same grade. So I'm not going to introduce some kind of peer evaluation or anything like that. So it's up to you as a team to work as a team to reach for the better result. Okay. That being said, invariably, there's always some teams that have some problems, communication problems. People are not responding in the beginning. Very important that if you have problems like this, if one of your teammates or more of your teammates are not responding, as soon as they start not responding, please contact me and I will make sure that they get on board. Okay. Teams get in trouble when they don't start working early. It's unfortunately a very common problem, human problem. Some people, they will start working on something only when they start feeling the pressure. Sometimes people have a tendency to start too late. If you start too late on my assignments, you will run into trouble. Okay, these are not trivial assignments that you can solve in a day or two. Okay, so I would advise that you regularly work on each of the assignments and don't think that you can solve all the assignment in the last days before the due date. So there's not going to be different grades for different people independently on how people are contributing. So if you have some problems with your teammates, contact me and I will try to solve the problem. It's not, don't worry about me judging people that are not responding or not contributing as much. My job here is to make sure that every team is working properly. So I'm going to try to be as gentle as possible in making people get on board of the train, if you see what I mean. Okay, close parenthesis on this. Next, graduate attribute, communication skills. So as you may know, and I'm a firm believer of this, communication skills is a very important skill for a programmer or software developer. Very often you're working as a team and you will see, if you don't have already realized that what is it, if you try to identify what is it that makes a very good teammate or a very good programmer, very often that is somebody who can communicate well, that can clearly explain what they're doing or a problem that they are facing. Or if somebody is facing a problem, they're trying to, they explain very clearly what is this problem and how to solve this problem to other people. Okay, so clearly what makes one of the great things that one of the things that make a great teammate as a programmer, a software developer, is how well they can communicate. Now, of course, you're going to have to do an oral presentation for each of your assignments. So that's one way that we're going to evaluate communication skills. We're going to also ask you to provide documentation in the form of comments inside of your code. And that's also how we're going to evaluate that. Now, for the evaluation. So there's going to be 3 different components or group of components. So the first, the midterm examination is going to be 20%. So this is going to be on the week 8. This is going to have to be on the weekend after week 8. I don't like give things on the weekend. However, here there are 2 sections. I'm teaching both of the sections. Doesn't make sense for me to write 2 different exams given at 2 different times. So it's going to be one common time frame for only one exam that is going to be written at the same time by both sections. Okay. So this is going to be worth 20% of your final mark. The final examination, there are 2 parts of the final examination. There's a regular written part, which is going to be essentially the same format as the midterm. So that's going to be an, I forgot to say, but the midterm is going to be an online exam. So there are different forms of online exams. What I'm going to do is I'm going to do a Moodle quiz or Moodle exam. And that's not going to be an invigilated exam. Okay, so don't worry about that. You just basically log on. You don't need a camera. You don't need anything like that. just log on to the exam and then you write the exam. It's a Moodle exam. It's not a COL exam. It's not an invigilated exam. It's just a regular Moodle quiz exam. So both the midterm and the final written examination are going to be exams like this. And then there's going to be, for the second part of the final examination, is going to be a programming exam. So still, it's going to be a modal exam, but in this particular exam, it's going to be that I'm presenting you with programming problems. Then I'm going to ask you to write C++ code to actually solve these problems. Okay. The written exams are not going to include really programming questions. The only programming questions that you're going to have are going to be on the final programming exam. So for the final examination, this is 50% of your mark. The written part is 35% and the programming part is 15%. Then there's going to be 3 assignments. Each assignment is worth 10% for a total of 30%. So that's a total of 100%. Then there's also conditions for you to actually pass the course. Okay, so of course you must get a passing grade for the overall mark, which should be around 50%. Okay, so even if you pass your exams, or let's say you have a stellar, typical is people have stellar marks on their assignments, and then they don't do so well in the midterm, which might bring them down and so on. So they may turn out to have below 50%. So you must have above 50% to pass the course. Other conditions, you must have more than 50% on the combined written and programming final exam. So even if you have higher than 50% overall, you must have higher than 50% for the combined written and programming final examination. And you must also have above 50% for the assignments. Reason for this one here is that I don't want people to only write the exams and not care about the assignments. Okay. So then after I have the numeric grades, then of course I have to compute the letter grades. Now, there's a myth running around that we profs must use the fixed letter grading scheme that is provided in the course in the academic calendar, which basically says A, B, and C, and D correspond to fixed numerical values. So you will find this in the calendar. Most courses in our faculty are not relying on this, as you may know. So is this course either. So what I'm doing basically is that I'm computing all the numeric grades. So that gives me some kind of distribution of the grades. And then what I do is essentially I construct a normal curve over the distribution of these grades. And then invariably what happens is that there is actually a bell curve like this. So then what I do is I say the top of the curve, the highest point on the curve is roughly the middle of the B minus, somewhere around B minus. And then following this curve like this, then I distribute the letter grades over the predefined numeric grades. Now, another myth, if you understood what I just said, here I'm saying I'm using a bell curve to distribute the letter grades over the pre-existing numeric grades. There's a different way you can actually do curving, which is actually to take the numeric grades, run them through a formula, and then alter the numeric grades so that they actually fit a normal curve that is defined using a predefined numeric to letter grading scheme, such as the one you will find in the academic calendar. That's not what I'm going to do. I'm not going to change your numeric grades. Your numeric grades will be fixed. What I'm going to do is to actually figure out which numeric grades correspond to which letter grade at the end. Okay. So please, if you have some questions about this is always a point of confusion here. How are the letter grades determined? Please, if you have some questions, we can discuss this either in class or in the Zoom sessions or in my office hours. So how are we going to do the lectures? So there's going to be 3 different things happening here. As I said earlier, so there is videos. So I have all the videos that are listed on the Moodle page and on my web page. And basically it tells you very clearly which week for which slide set each videos are associated with. Okay, the videos themselves cover all the material. There's never going to be any material that is going to be presented outside of the videos. So if you want to absorb the material, you have to listen to the videos. Don't expect that there's going to be other places like in the lectures. I'm going to present other materials that are not in the videos. Okay. So that's why when I give, for example, the in-person lectures or the Zoom lectures during the official lecture time, I'm going to expect that you have listened to the videos for this week. Okay. And then when you come to the lecture time, I'm going to expect that you have some questions about the material that was covered in the videos for the week. So there is the videos, and then is the synchronous online Zoom lectures. So there's going to be one of them every week. And then there's going to be, because every two sections have 2 lectures per week. There's going to be one of them that is a Zoom lecture. The other one is going to be an in-person lecture. So whether it is the Zoom lecture or the in-person lecture, it's going to be the same thing. Basically, what I do is I come in front of you, and then I present somehow selected things that I thought is important to understand in the material for the week. Then I open the floor for questions. Okay, so that's what the either the Zoom lecture or the in-person lecture, that's what I'm going to do. Just present roughly everything that was the important things that were discussed in the videos for the week, then have some discussions about these topics, and then open the floor for questions. Well, this is how the course is going to go. Videos and lectures are, one is on Zoom and one is in person. If you want to know which one is which for your particular section, look at your Moodle page. What about the labs? So it's the same idea for the labs. So there is already on the Moodle page, you will see the material that is going to be used for each of the labs. Okay. So these are essentially sample C++ programs that the lab instructor is going to explain in videos. And so for every of the lab sessions, there's going to be the lab material and a video that is going to be produced by one of the lab instructors. For the labs, though, there's going to be only one or actually 2 different lab sessions that are going to be in person. All of the lab sessions are going to be Zoom sessions, except for 2 of them. So there's going to be one that is at 5:45. That's going to be a live session in the hall building. And then one in the evening session, lab session, that is also going to be an in-person session in the hall building. Only 2 of them are going to be in person. If there's more demand, we may increase that to more number of in-person sessions. But I mean, let's face it, a lot of people are not very, how can I say, hot about going in person. There was quite a few lab instructors that I've contacted that specifically said, I don't want to be in person because they they are afraid of the COVID. They don't want to be in person to increase their risk of getting COVID. So yes, so that's why there's going to be only a few lab sessions that are going to be in person. Because there is only a few, of course, I will allow anybody to go to these in-person sessions. Okay. If there's too many people, we may consider to increase the number of in-person sessions. But in the start, it's going to be only 2 of them. So what's going to be again, it's going to be the same thing. Material is on the Moodle page. There's going to be 1 video for each of the weekly lab sessions. And then during the lab session time, there's going to be a Zoom session or an in-person session associated with each of the lab sessions. And during the Zoom sessions or live or in-person session, what the lab instructor is going to do is to essentially highlight the important things that were discussed in the video about the material, and then be there to answer your questions. Objectives in the labs is first to go in more details about the examples that were presented in the video lectures, potentially give more examples if that's necessary, and then answer questions about the examples. And of course, also help working on the assignments, which are, essentially the project is asking you to use the things that were presented in the lab sessions in the context of a particular project. For the assignments and the project, it's highly recommended, even though I cannot enforce it, that you actually use an online versioning system. More and more there, I would say if you are being serious about being a programmer or software developer, you have to use a versioning system like GitHub or Bitbucket or whichever you are using. If you don't know any of these things, you should seriously consider to learn how to use it. Invariably, if you have a team of 5, there's going to be somebody in your team that knows how to use it. If you are this person is in your team, and that's a good opportunity for you to, teach other people how to use it. What they say, the best way to learn something, to master something really, is to teach it. So if you have to teach somebody else how to acquire some of your skills, it's actually good for you. Okay. And if you are somebody who do not know these tools, please be very open-minded and realize it's also very good for you. Because if you do an interview to get a job and you don't know versioning systems, that's not going to be good for you. If you know how to use, for example, GitHub, go to an interview, that's already a good plus for you. So it's a good thing to learn. Though again, this is not in the learning objectives of this course. I'm not going to enforce that you use it. The demonstrations will be done online using Zoom, and then the presentations are going to be very short, only a few minutes. Okay, so there's you will see that there's quite a few things to present. So it's very important that you come prepared to your presentations so that you don't lose time. Example, struggling with your own code and so on. So you should rehearse your own presentations to make sure that actually fits in the time that is allocated. For the examinations, as I hinted at before, so there's going to be the midterm. So it's going to be using a Moodle examination. It's going to be no invigilation, and this is going to be on the weekend after week 8. For the written final examination, exactly the same. Okay, and then even the format of both of the exams is going to be very, very similar. Okay, so if If you do well in the midterm, you should expect that the final is going to be very similar. So it's essentially a midterm is kind of a rehearsal for the final exam. If you do well in the midterm, very likely that you do well in the final. Don't expect that the final is going to be something very different. Then there's an online programming final exam. So you're giving some programming exercises. Either you write some code from scratch, you fix some code, or I'm giving you some code and I'm asking you to change it or add things. So using, again, a Moodle examination. So I'm giving you the questions in Moodle examination, and then you have to zip your code solution and then upload it in the Moodle examination. So this is going to be the programming final examination is going to be in the lab on week 12. On week 11, there's going to be a rehearsal for this exam. So I would strongly advise that you attend this rehearsal on week 12, for the simple reason that it's the operation of the exam is quite different from the midterm. So if you want to get used to or to somehow expect what is going to happen, the style of questions, how to submit your code, and so on, it's very important that you attend a rehearsal on the week 11 of the lab for the programming final examination. So finally, here's a selected bibliography that resources, books, articles that I know that I've used myself. I own many of these books, I've read many of these books. So these are the best resources that I know about C++. This year, I used to have this book here that was my main resource, but it's not available online anymore. However, there is Walter Savage's Absolute C++, which is available, which I made available in the library. However, it's not a mandatory book, so you don't need to have this book for the course. The other one is Bjarne Stroustrup's C++ programming language. So if you ask me which one is best book, it depends on what you are looking for. Okay, you may know, for example, Absolute Java book. Absolute C++ is kind of a copy-paste of the same book as Absolute Java, but applied to C++. So it's more, Absolute C++ is more like an introduction to programming using C++. So it's a more basic kind of book. If you want to have more than basic, the absolute best book to have invariably is this book here. Okay. However, if you know Bjarne Stroustrup is the guy who invented, the man who invented C++, wrote it himself. He is notoriously somebody who is going into all the details of everything that he's explaining. Okay. And if you know your C++, you know that there is a lot of details and he's not sparing you any of the details. So if you are struggling with the concepts or the implementation, you will find this book to be actually very confusing. It's going to introduce concepts that you have no idea about. If you're not a seasoned programmer and you read this book, you're going to probably be more confused. It's not going to be helpful to you. It's going to be more confusing than helpful. If you are a more junior person, no offense with that. That happens. This is why we have courses, and you better use this book here. But if you like to learn more seriously about how C++ actually works, then you should rely on this book here. Okay. There are other books that, as you see here, that are useful, but that's the main two that I'm using in this course. There are also some documentation There's extremely valuable websites that are describing the C++ language in all the possible details in a way kind of similar to what I was describing here. So for example, if you go to CPP reference or C++.com or ISO CPP or Microsoft C++ language reference, you will find an answer to every of your questions. However, these are going to be extremely technical answers. Okay. So if you want to know every possible answer to your question, to every possible question, go there. But be ready that there's going to be a lot of things that are going to be, it's going to be a flood of details, technical details that are going to be given to you. So even me, that I know a lot about C++, very often when I go to, for example, CPP reference, invariably when I go there, every time I go there, I learn something new. Okay. It's C++ is kind of a never-ending story. Even if you're extremely knowledgeable, invariably you come up with something that you did not know. Okay. Every day is a new learning experience with that kind of language. If you are looking for a more, I would say, mundane kind of help, then there is, of course, a Stack Overflow is good. Well, what you have to be careful about Stack Overflow, as you may know, is that, like, no, Stack Overflow is a little bit like Wikipedia. Yes, you have good answers, but you have bad answers. And then if you don't know how to make a difference between what is good and what is wrong, then you may be misled by some information that is presented to you on Stack Overflow. Okay. So if you know your things about C++, if you're knowledgeable about C++, Stack Overflow might be useful for quick references about things that people are discussing. But sometimes people are plain wrong or misleading when they have these discussions on Stack Overflow. So you have to be careful about that kind of resources. There is also some tutorials, public tutorials like Tutorials Point, Geek for Geeks, and Programmiz. That is 3 of those that I found were consistently good. Okay. Not saying that there's not other than these, but that's some of those that have identified myself as being useful. So that's it for this introduction. So I will, welcome everybody to this fall 2021 semester, and see you in class.